Hello, everyone. My name is Huabo Su. I'm from Augusta University. I have with me Henry Cohen, who is the finalist of our 2025 BCVS Outstanding Early Career Investigator Award. So congratulations on making to the finalist.
Thank you.
To start us off, could you give us some background about yourself and what initially drew you into cardiovascular research?
Yeah, of course. It's a pleasure to be here. So I grew up in Pittsburgh, Pennsylvania. I went to undergraduate at Washington University in St. Louis. I studied mathematics and biomedical engineering. And then I matriculated into the MD PhD program at Temple, where I met John Elrod. And when I met John, when he started talking to me about his work, I just found it very motivating and really interesting. And so I rotated in John's lab, and we get along great. And so, yeah, I joined his lab for my PhD after finishing the first 2 years of medical school in 2021. And I recently defended my thesis in this past April.
Oh, that's fantastic. Could you tell us a little bit what's your presentation about today?
Yeah, so the work that I presented today, it's long been known that there's a relationship between mitochondrial calcium and metabolism. And it's long been thought that this relationship exists in the mitochondrial matrix, and that with increased stress, there's increased calcium uptake by the mitochondrial calcium uniporter, which serves to activate calcium-sensitive enzymes within the matrix to increase ATP production. But when you delete that transporter, not much happens, in the absence of stress, that is. With stress, in many tissues, it's protective to ablate function of the uniporter, but at baseline, you can delete the uniporter, and the animals are totally fine, and metabolically, they're unperturbed. So the project really went into how is it that calcium regulates metabolism in the absence of stress. And what we found was that there are metabolic enzymes and calcium-binding proteins in the intermembrane space that basically orchestrate the formation of these kind of multi-protein complexes in response to calcium signaling. And we think it's a fundamental mechanism by which metabolic supply and demand are matched.
Sounds very interesting. So this is very groundbreaking or paradigm shift discovery. So congratulations on that. Could you tell us a little bit from a physician scientist point of view, how your finding could potentially impact how we treat patients with cardiovascular disease?
Yeah, we think this work is really relevant to any pathology that's defined by altered calcium signaling or by metabolic derangement. And in effectively all diseases, you will see both of those things. Most importantly, I mean, this week we've heard a lot about HFpEF, or heart failure with preserved ejection fraction, and that's a pathology that's defined by altered calcium signaling and altered metabolism, both at the level of the patient. These patients often present with some form of metabolic syndrome, and on the more molecular level, at the level of the cardiomyocyte, in the form of altered fuel selection and utilization. So what we've seen is that in our animal models of HFpEF, you have alterations in some of these metabolic enzymes that we think are forming calcium-sensitive metabolons, and also altered transcripts of the proteins that we think orchestrate these metabolons and their formation and dissociation.
Moving forward, what do you think are the questions you will need to address in order to move this field forward?
Yeah, so we think that, the presentation that I gave today, we described one of these metabolons, but we think this is a shared phenomena across many other metabolic enzymes. And so we've continued working up other hits from our screens, and we think this is just the first of many stories to come out of this line of work.
That's fantastic. So you did very well in the presentation today. So congratulations making to the finalists, and I wish you the best of luck in the competition.
Thank you very much.